Hello. Today we are going to be talking about Congruent Triangles 1. So first, bit of a review. This is from a few videos ago, so yeah. We have postulates, which are statements of fact accepted without proof. We have axioms, which are statements of reason. Accepted without proof. Now finally, we have theorems, which are a combination of postulates and axioms to prove something true. It's a statement proven by postulates and axioms. So, next, we're going to be looking at some congruency postulates. So, if we were to define congruent, we would define it as, congruent triangles would be defined as two triangles that they can, basically, you can pick one up and you can place it on top of the other. They look exactly the same. I can't freehand draw two triangles exactly the same. But, yeah, we can think of these triangles, A, B, C, and E, F, G, as the exact same. And we can write that by writing a triangle, the name of the first one, ABC, then this symbol right here, which also means approximation, and then the other triangle and its name, like that. Now, there are three postulates to establish congruency. Those are SSS, ASA, and SAS. Now, brief explanation of what those are. SSS is if you have two triangles, and you know that all three sides are the same, like so. That proves them congruent. The next one, ASA, is where you have two angles, like so, that we know are the same, and a side in between them. So all we need is just this bit over here to prove that these two are congruent. Then lastly, we have SAS, where it's the opposite of ASA. If we have two angles, I'm just gonna like that. If we have one angle that we know is congruent between the two triangles, and two sides surrounding the angle, keep that in mind, this only works if they're around the angle, then we know that these are congruent. But it wouldn't work, say, if the angle we had was this one, and we had these two sides congruent. Now, there are also two theorems that you can use to prove congruency. Those are AAS and HL. Again, brief explanation of those two. ASS is where you have two triangles. You have two angles, like so, and a side length that is not in between the two angles. So not here or not here in this case. And finally, HL, I'm going to draw over here. If you have a right triangle, it has to be right triangle, and the hypotenuses of those triangles are equal, or congruent, then we know that these two triangles are equal. So, really quick, before we move on to our final topic, let's go ahead and prove ASS. If we have two triangles, like so, triangles ABC and EFG, we can prove congruency. so basically we're going to be given, we get this angle, angles A and E are congruent, angles C and G are congruent, and side lengths CB and GF are congruent. We can actually prove congruence. Let's make a 2-column proof, or 2-column chart, statement and reasoning. So first, we're given that angle A is equal to angle E. That was given. We also know that angles C and angle G are congruent. Also given. And we know that line segments CB and line segment GF are congruent, also given. Now we know that all three angles of a triangle have to add up to 180. So that's going to be our reasoning for steps 4 and 5. We know that A plus B, angle B plus angle C is 180 degrees. And we know that angle E plus angle F plus angle G equals 180 degrees. And your reason is that triangle angles add to 180. Alright, but how does that help us? Well, you see, our next step, two things that are equal to the same thing are also equal. So we could write that angle A plus angle B plus angle C is equal to angle E plus angle F plus angle G. And we can, two things that are equal are equal to the same thing. The same thing are equal. But again, how does that help us? Well, here's what we could do. I'm going to abbreviate this so we get it. But basically, something equal minus something equal is equal. So what we can do, I know it didn't make a lot of sense, is we can basically cancel out the A and the E. So we have angle B plus angle C equals angle F plus angle G. And again, the reasoning behind that is that if two things are equal and you subtract them both, it's still equal. It's like if we had 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. 1 and 1 are equal. We can take them both out, and 2 plus 3 is still equal to 2 plus 3. It's the same case here. We can do that again for angles C and G. So we get just that angle B is equal to angle F, again by the same reasoning. Two things, equal thing minus an equal thing are still equal on lines 6 and 2. I forgot to mention it on the top one, but our reasoning by that is lines 5 and 1. And that's it. Because now that we've proven that these two are also equal by a different one, we have side angle side. Right here we have side angle and angle. Sorry, it's angle angle side. No, angle side angle. I always get these mixed up. We have this case, which means that these two are congruent. Now, final topic. We're going to be proving that in a given isosceles triangle, we draw one, that these two base angles right here are equal. Now, in an isosceles triangle, these two are equal. What an isosceles triangle means, the definition of an isosceles triangle, is that two of the side lengths are equal. So a triangle like this, or say, in a triangle like this, if these two were equal, that'd still be an isosceles triangle. Now, given that triangle ABC like so, is isosceles. We're going to be proving that these two angles are equal. So let's make another 2-column chart. We have statement and reasoning. We know that triangle ABC is isosceles, and that is given to us. Now, as I already explained, by definition of isosceles, line segments AC and CB are congruent by, again, the definition of an isosceles triangle. I can't spell. So, what we can do now is we're going to construct a line CD, which we're going to put D down here, where C is bisected. So basically, we're splitting angle C perfectly in half. So now these two halves are congruent, which, yeah, we're defining in the next step. So this would be by construction. Next, as I already said, we know that angle ACD is equal to angle DCB. Or actually, it'd be BCD. Yeah, by def of angle bisector. Like that. Now also, line CD, we can write CD equals CD. Because everything is equal to itself. Now what this means is that we know that triangle, we made two triangles here. Triangle ADC is congruent to triangle BDC. BDC. And reasoning by that is side angle side. Steps 2, 4, and 5 prove that. 2 means that these two are the same. Step 4 means that these two angles. And step 5 makes this line equal to itself, which means that these two would both just be the same line, just overlapping, which means we have side angle side here. And that means that angle A is equal to angle B. Yeah, equals angle B. By, this is, it's abbreviated CPC plus C. And basically what that means is we can take this, flip it over, and put it on top, and angles A and B would be the same. In other words, like, since they're the same triangle, these two angle measures have to be the same. And that proves that these base angles are equal by